Let's graph absolute value functions. This is Learning Target 8 in Unit 5, absolute value. If we graph y equals x, we get this line. It has a slope of 1, it has a y-intercept of 0. What happens if we want to graph the line y equals absolute value of x? Well, let's pick some ordered pairs and see what we get when we plug in absolute value. If I've got x is -5, then the y value is going to be, well, what's the absolute value of -5? Absolute value means the distance from 0. It's 5 units away, so we get 5. The absolute value of -2 is 2. The absolute value of -1 is 1 because it's 1 unit away. The absolute value of 0 is going to be 0. If I take the absolute value of 2, that means the distance from 0, I get 2. The absolute value of 4, the distance from 0, is 4. So I have a table of values. I can start plotting these points. -5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. There's my first point. -2, 2. -1, 1. 0, 0. 2, 2, 1, 2, 1, 2. And 4, 1, 2, 3, 4, 1, 2, 3, 4. So you can see we get what we call a V shape. Our absolute value function will be graphed and look like this, a V shape. What it's doing is it's taking the other side of this line of y equals x and it's reflecting it over the x-axis, making it positive. So we call this a V-shaped graph. Let's go to our graphing calculator, go to y equals, let's turn any plots off that we have, clear out any old equation, and let's graph y equals absolute value of x. So to do absolute value, you go math, to the right for number, and then abs is number 1. So you get math num abs. Then you put an x in there, an arrow out. You get the absolute value of x. I want to go zoom 6 to make sure my window is -10 to 10, -10 to 10. And you can see I get a V-shaped graph. All absolute value functions will have this characteristic of a V shape to it. Let's go back over here. Remember, our linear equations in slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. The graph is a line. Our absolute value equations will be a V-shaped graph. Some vocabulary that we use to show what's happening with our parent function being the absolute value function, we use terms like translate up the graph, translate down the graph, translate left, translate right. We also say that V shapes open up like this one. They also open down like this one. They can be narrow, they can be wide. So you can talk about the V shapes being narrow and wide as well. So these are terms that we would use to describe a graph. Graph y equals absolute value of x, then graph y equals absolute value of x plus 3. What happened to the graph? Let's graph both on our graphing calculator. So let's go back to y equals here. And we're also doing, in our second equation, math num abs. And we're doing an x, arrowing out, and we're going to add 3 on the outside. So we go to graph, and let's see what happened. It looks like our parent function, the parent one being the blue, translated up the graph. So what we're going to do here is we're going to graph the original in blue, and it was this. This is our parent graph, y equals absolute value of x. The parent function was translated up the graph, 1, 2, 3, to where that vertex is now translated up 3 units. Therefore, when you add a number outside the absolute value, you translate the V shape up. Make sure you add that to your notes. What do you think happens if I subtract 4? Let's go to the graphing calculator, arrow down and over, and let's subtract 4. Then go to graph. It translated down the graph 4. So in graphing these two, we have our parent function, the blue one, is this one, our absolute value function. And then we have the new function, minus 4 on the outside, translated down 1, 2, 3, 4. Translated down the graph 4. Therefore, when you subtract a number outside the absolute value, you translate the V shape down. Oops, almost put downer because I'm used to always typing downer. Okay. Look at what's different in this. We're adding 5, but not on the outside. If we did add 5 on the outside, we'd probably translate up the graph. But in this case, we're adding 5 on the inside. So what would be your prediction? What do you think will happen? Well, let's go down to our second equation, clear it out. We'll do math num abs. And we're going to have x plus 5 on the inside. So x plus 5. Arrow out. Make sure you have both those equations in and go to graph. There's our parent function. So let's graph that. We got the parent function that looks like this, the blue, and look at the red. It's translated not to the right, but to the left 5. 1, 2, 3, 4, 5. It translated to the left 5. Now, when you add 5 on the inside of the absolute value, one might think that you need to translate to the right because it's a positive 5. But because it's inside the absolute value, you need to translate to the left 5. In terms of distance from 0, the way to make this 0 is by plugging in x is negative 5. So you can think of it in terms of on the x-axis I'll be at negative 5 because negative 5 plus 5 gives me 0, distance from 0. So therefore, when you add a number inside the absolute value, you translate the V shape to the left, not the right like you would think. To the left. Add that to your notes. What do you think will happen if we subtract a number inside the absolute value? Let's go to the graphing calculator and see. So we're going to revise this to be minus 2. Go to the graph. You've got your parent function. And then what happened to the parent function is you translated to the right 2. So we translate to the right 2. So when you subtract a number inside the absolute value, you translate to the right. The V shape translates to the right. What do you think happens if we have a negative on the outside? So when you place a negative before the absolute value, what will happen to the V shape? Let's go to the y equals, go to the second equation, clear it out, and let's go negative down here. Then math num abs, negative absolute value of x, and I'm going to graph it. There's our parent function. Let's graph that. And what happened to our parent function is we ended up flipping it. It ended up opening down. So when you have a negative on the outside, our absolute value equation opens down. Add that to your notes. Look at this equation. We're taking the absolute value of x, and then we're going to have a negative. We're going to add 6 on the inside, and we're going to subtract 2 on the outside. What happened to the graph? Well, before we graph it, let's look at the equation and try to describe what we think will be happening. Because of the negative, and because of the adding 6, and because of the subtract 2, let's describe what will happen with each thing. Because of the negative on the outside, it will open down. Because of the negative. It will also translate, now because it's inside the absolute value, I would think to the right, but it's just the opposite, to the left 6 units. And because of the subtract 2 on the outside, it will also translate down 2 units. So it will open down, it will go to the left 6 units and down 2 units. So let me graph what I think will be my absolute value, and then I'll check it with my calculator. Opens down to the left 6, 1, 2, 3, 4, 5, 6. My vertex will be translated to the left 6, down 2, 1, 2, and it opens down. So from this vertex, I'm going to do my 2 sides. That's what I think it will look like. Let's go over here. Let's clear out these 2 equations. Go back up to the first, do math num abs. Oh, we want to put the negative on the outside. So we need to do negative math num abs. So we have x plus 6 on the inside, and then on the outside we have minus 2. So make sure your equation's correct and it's not a minus. It needs to be a negative. And then go to graph and let's see if we get the graph that we did. We do. So you can tell by looking at the function how it will be translated because of our investigation. Pause the movie, try this one on your own, do the graph, and then let's test it out and see if you got it right. So I see a couple things here in the equation that I think will happen. Because of that minus 4, I think it's going to go to the right 4. And because of that plus 1, I think it's going to translate up 1. So to the right 4, 1, 2, 3, 4, and up 1. Let's see if I'm right. I think it will look like this. So we go to the graphing calculator to see if we're right. Go to y equals, clear out the old guy, do math num abs, and we get x minus 4 on the inside, and then on the outside we get plus 1. Go to graph. We go to the right 4 and up 1. That is indeed what we get. So we guessed it by looking at our equation first and how it would translate on the graph. So here's a synopsis of what we learned. Outside the absolute value, if it's positive, it opens up. If it's negative, it opens down. Inside the absolute value, if it's positive, it translates left, sort of just the opposite of what you would think. And if it's negative, minus a, then you translate to the right. On the outside of the absolute value, if it's positive, you translate up, and negative, translate down. Without graphing, describe 4 facts of what this would look like, and then you can graph it to check yourself. Pause the movie, try this, and press play when you finish. Okay, because of that negative, I think it will open down. Because I added 8 inside, I'm going to translate to the left 8 units. And because I have minus 1 outside, I'm going to translate down 1 unit. And because it's an absolute value, it's a V-shaped graph. So it's all of those things. And you can graph to double check yourself. That's all we're going to have for today. Thank you for watching.